Here we go. So your exam's coming up on Wednesday. So there's going to be a official 60-minute time limit on that. What I'm going to do is I'm going to write approximately a 40-minute exam. I have this thing that I do that tells me approximately how much the quote-unquote average student should take on an exam. So it'll be approximately a 40, maybe 45-minute exam as I've written it. That doesn't mean that everyone will necessarily finish in 40 minutes. Some people might finish early, people might need to take a little longer. So the class is 50 minutes, of course, but I will give you a 60-minute time limit. I will also open the exam up a little bit early, maybe 20 minutes early, so that if you have a class directly after that you would need to get to, but you want to allow yourself to have that extra 10 minutes if you want, that'll be a thing as well. You don't need to be on Teams, but I will be here to answer questions. So also if you just want to come into Teams and just sit here, and in case you have questions, feel free to do that. Your homework for this week, I was very optimistic for how much stuff we were going to cover this week, and we did not get there. So there is a subset of this homework that you can do. I think about the first 15-ish questions, I think. But then the second half is more about logarithms, which we haven't talked about yet. So I would suggest you pretend that part of the homework, and I'll try to figure out what actual numbers you can do and put them on an announcement on Blackboard. I didn't have time to do that yet, but I'll tell you what problems you can do. I would highly suggest pretending that they're due on Monday and just getting those ones done so you have the practice for the exam. But the due date for that entire homework is going to be changed to 2/15 so that we can actually finish up the rest of that content. The logarithm section is not that long, so we should finish that on Friday after your exam, the day after your exam. So that's a thing. We'll talk more about the exam on Monday. Okay, I'm hoping to take a little bit of time on Monday for a review session. If we need to finish up a little bit of notes, we will do that. But that's why I kind of want to hop in today to get through as much as possible. So that's a thing. And so we'll talk about more about the format and all of that about the exam on Monday. I don't want to field those questions right now, so we can get into this. So we'll talk more about the exam on Monday. SI sessions. Zoe's our one here, right? I can never remember if it's Zoe or Peyton. I'm pretty sure it's Zoe. No, she's not here. No. Zoe's not here. Okay, 1 second. Let me try to figure that out. I know most of the time they do them through Blackboard. If anyone has attended an SI session and knows the answer about whether or not they're on Blackboard, that'd be great. If you could let me try to pull up Zoe here. Yeah, so she's got some, she uses Blackboard Collaborate, apparently. It was on Blackboard, yeah. So in chat, ooh, that came out kind of weird, but in chat, apparently she's got 2 different links, one for Sunday, Monday sessions and one for Wednesday sessions. But you should also hopefully be getting some information from her about test review soon. If I see her pop in later, I will ask her, but currently she's not here. All right. So yeah, they're on Blackboard. The links are in there. All right, so let's get started on our notes. Oh, one last thing I want to say about the exam. Again, we'll talk about the actual format of it on Monday and everything like that. There will be a review that's going up later today. I don't know exactly when. I have to tweak it a little bit, but it will be up by the end of the day on Blackboard. There will be a new folder under course content called exams. It'll be in there. There will be a review. I'll be posting the blank review today, and then in a day or so, I'll get the answers up as well. So if you're trying to study for the exam, that is the thing that I suggest doing first, okay? Because, you know, the web work homework is, of course, good, but I don't write the web work homework questions. They're just pulled from a large question bank, and I write the exam and I write the exam review. So the review is going to be most similar to the exam. So again, we'll talk about that a bit more on Monday. So let's get into this. So remember, we're talking about exponential functions, and let's remember what those look like. So remember, we've got our exponential functions. They're made up of an initial value and a base or a factor. And that base or that factor, remember, is made up of this 1 plus r. So if we go back down to that question we're going to look at first, question 3. Mildred collects hats. In 2014, she began with 25 hats, and she plans to increase her collection by 25% per year. Write a formula for h of t, the number of hats Mildred would have after t years after 2014. How large will her collection be in 2020? The one thing I want to note here is very common with exponential function questions, and that's the fact that we're setting the t value, the x value, if you will, to be essentially years after a certain point. That's going to be highly common. Every once in a while, they might just have you use the actual years, but that's very rare. But just make sure to read the question fully and make sure you're using the correct values if you ever need to plug in values for these. So to write an exponential function, we need two things. We need the initial value and we need the base, which might be made up of a 1 plus r. Now, the initial value is essentially the value that you start with. So we're told that she starts with 25 hats, so the initial value is going to be 25. Now, off to the side here really quick, we're told that this is going to grow by 25% per year. Whoops. So if you see the word percent or you see the word rate or something like that, it's going to give you the R value. If you see factor, or I don't think they'd say base, but if you see the word factor, that's going to be the A value. So here what we're actually told is we're actually told R. And the one last thing to remember about R is you need to change it from a percent to a decimal. So we'll need to make R 0.25, which makes our A value 1.25. I'm okay with that so far? Okay. Which makes our equation 25, 1.25 to the t. Now we're also asked how large is her collection in 2020. And we have to remember that this is in t years since 2014. So 2020 is going to give us a t value of 6. So for the last part of this question, we want to plug in 6 for our time. If you punch that into a calculator, you should get 95.37. That would be an acceptable answer, but since we're talking about hats, why don't I just say about 95 hats? So we had our initial value was given to us. We were given the percent that it was increasing by. That's the other thing. Since we were increasing, my rate was positive. If you read a question and it says it's decreasing, you need to make the R value negative. So that's another thing to keep an eye out for. If it says decreasing, your R value needs to be negative. If it says increasing, then your R value needs to be positive. There's never a time where the A value would be negative. Remember that. So if it says factor, it's just the value as it stands. So if there are no questions on that, we'll go to the next one, which is suppose you invest $800 that earns 7% interest per year. Come up with a formula for how much money you will have in t years. So this is another exponential function. We need our P naught and our A value. Our initial value, we're starting with the investment of 800. We're increasing because the interest makes it go up by 7%. So our R value would be 0.07. So the A value is 1.07. Okay. So our equation, 800, 1.07 to the t. Okay. I just want to come off to the side and do a kind of side note. So this doesn't have to do with this question at all. This is kind of going to be a separate question, but I just want to, I don't think the other question, yeah, the other question is still increase. Say this was, you know, my friend gave me $800 and they just wanted me to repay them eventually. And I decided that I was going to pay them 7% of the balance each year. So say I was trying to like pay this off and say for some reason it was decreasing by that 7% for whatever silly reason you want to think of. Just to clarify, so since it would be decreasing, we would be subtracting the R value because the R value would have to be negative, which would result in an A value of 0.93. Yeah. So remember when we defined exponential growth and exponential decay, exponential growth was for an A value greater than 1, and then exponential decay, the A value turned out between 0 and 1. So that's what's going to happen when we subtract that rate off, is it's going to just leave us with a decimal that's less than 1. So that's just a side note because we haven't looked at one with decreasing yet. I don't think this page actually has any, which is unfortunate. Questions, concerns? Okay. Now, this next question is kind of about phrasing. So, well, actually, this one kind of gives it to you. But anyway, your boss proposes 2 different plans for giving raises. Suppose your current salary, you currently earn $35,000 per year. In the first plan, you add an additional $1,000 each year. In the second plan, you increase your salary by 3% each year. Which plan do you think is better? Check your guess by computing your salary after 5 years and after 10 years under both plans. So this is actually very similar to the kind of warm-up question from this section of notes, but we'll look at that in a second. Sorry, Sia, decreasing would mean decay. Yes, so that's actually a really good question. Sometimes it won't say decreasing exactly, it will say decay. We'll see some types of questions in another section where they say decays by or something like that. So if you see the word decay, it's meaning it's decreasing and it's going to be a negative R value. Thank you. That's actually a really good question because I should specify that. So we have this first plan that is actually going to end up being linear. How do I know it's linear? I know it's linear because it says $1,000 per year. So it's essentially a set value each year. It's not going to change every year. It's just going to be that set $1,000 every single year. So that's actually going to give me a linear relationship. So if I want to find, you know, the total amount of money that I have after a certain amount of years, if I'm starting at the 35,000 and I'm adding on 1,000 every year, that's just going to be a linear relationship of our y equals mx plus b, but in this case we're going to use t because that's usually used in these situations with time. But if you want to put an x, go right ahead. And before I calculate the 5 and the 10, let me go over to the other one. So the other one would be exponential. So what tips me off to the fact that it's exponential is the fact that it says 3% per year. So I know that it's still per year, but that value is actually going to change because the 3% is going to be on whatever your current salary is. And if your current salary is increasing, then the 3% of your current salary is going to change every year. So since it's a percent and not an actual just set value, that tips us off that it's exponential. So our equation here, so our initial value would be that 35,000. And here that 3% would be our R value. So our A value would be 1 plus that, so 1.03. Just to make it super clear where that 1.03 comes from. So now we've got our 2 equations. Now we can find the salary after 5 and 10 years and compare them both. So 5 years, 10 years, 5 years, 10 years. So of course with these we're just going to plug in 5 and 10 respectively. I'm probably just going to write out the 5 one and then save myself some time and not write out the full 10. So if we plug in 5 to the linear, we're going to get 40,000. If we plug the 10 into the linear, we're going to get 45,000. I'm not going to write out the full format for that unless someone really wants to see it. And with the exponential, we're going to do the same thing. Plug in 5 and then plug in 10. If we plug in 5 to the exponential function, we're going to get 40,574.59. And if we plug in 10, we're going to get 47,037 and 7 cents. So obviously, if you're trying to make more money, in this case, for this problem, the answer would be that the exponential function is better. The 3%. I believe, if I'm not mistaken, whoops. Oh no, it's even better in the first year too, because you would get 1,050 instead of just 1,000. I was gonna say I thought maybe it was not better in the first year, but. And of course, the more years you stay there, the larger the gap between the two would be, so you would want to take the 3%. Questions, concerns about that? So the one thing about this question to pull is a set amount per year or per whatever time frame you're talking about would represent a linear relationship, and a percent increase or decrease would give you an exponential. All right. Wait like 5 seconds in case anyone needs to catch up. So the next thing we need to talk about is essentially how to find the exponential function, an exponential equation for an exponential function, if we're not given necessarily the initial value and the rate. What if we're just given 2 points? So just like we could find an equation of a linear line given 2 points, we can do the same for an exponential. So there are some things to write down. I know this looks full, but we're going to write some things out. So to find the equation of an exponential function given 2 points, you can use the following process. Certain problems can be solved slightly faster. There's like one tiny bit of a shortcut that you can take, and I'll try to point that out when we get to one. But this process always works. So if you just want to focus on the process that always works and not worry about the shortcuts you could possibly take, that's a thing. So the first thing you're going to do is you're going to take both points and you're going to write them in the form p equals p naught a to the t. You're essentially going to put them into the function format that we want them to have. Now note that the things you're actually plugging into are the p value in the back and the t value in the front. I should be careful at the front. The t value in the exponent and the thing that's actually solved for. The p naught and the a are the things we're going to need to find, and that's what this process is going to do. The next thing you're going to do is you're going to divide the two equations that you write. And you'll see what I mean by that in a second. And I always suggest to therefore write the equation with the larger t value first so that you can put that on top of the other one. Because if you have the larger t value equation on top, it's going to make the algebra easier. You can technically solve it the other way. It's just going to be a little bit grosser algebra. So I would always say take the larger t value and write that equation first. What you're going to do after you divide, and we'll see what happens when we divide these in a second, is we're going to be able to solve for the a value. And once you have that a value, you're going to take that a value you find, you're going to plug it into whichever function makes you happier of the two that you originally wrote out, and that'll allow you to solve for the p naught. This is the main thing that can sometimes be shortcutted. So sometimes you can shortcut finding the p naught because one of the points will be the p naught. You can always do this full process out even if you're originally given the p naught. And I'm going to do that for one of them because it's going to come out slightly different for a reason. And I want you to see that. So that's the process we're going to use. And so I'll hold on for 5 seconds in case people are still writing that down. So let's do a couple of examples. So we've got 3 examples here. We're going to split these up so we have enough space. And actually, I'm going to move that over because the middle one's going to be the most squished because it doesn't have the extra space on the sides. So, number 4. What was number? Oh, 4. The answer was this. And the side note off to the side was just a random side note. Oh, on the notes part. Sorry. If it'll let me scroll down. The official thing was P naught, and then there was like a little side note of that's the main thing that you can sometimes shortcut. So let me know when you're good. Cool. So we're given 2 points here. So the one is going to be 0, 100, and the other one over here, if you just look at what the values are given strategically, the point and the things that are listed off the side. So this point is 3, 21.6 is that point there. Now, again, this is one where we technically have P naught. P naught is going to be 100. I'm going to go about this question as if I don't know that. Okay, so I'm going to do the full process out, and we're going to see something pop up. Now, these questions are a bit long. How much space do I have down there? So let me zoom out a little bit maybe. There we go. So try not to write too big if your handwriting like mine is kind of large. So I'm gonna, since I'm doing the full process on this one, I'm gonna split it into 2 columns so that I definitely have enough space. So the first thing is to write both of those equations in the P equals P naught A to the T form. So let me write the generic form up here just so that we have it. I'm going to take the larger x value, t value, whatever it is, first. So since the larger x value is 3, I'm going to write that equation out first because that's just going to make my algebra easier when I do the next step. And then I'm going to write the other one, whoops, below it. If you write them side by side, you're then just going to have to rewrite them on top of each other. So just save yourself some time, just write them on top of each other. Because what we do then is we divide the 2 equations. So, see, the large majority of the time, yes. There might be a one time where it's the opposite for some strange reason, but I know that it's XY here because this is my horizontal and this is my vertical. Usually, if there's going to be a t value, it's usually going to be the horizontal. But in this case, we can kind of know which one's which based off of which variables attached to the horizontal axis and which one's attached to the vertical axis. But the large majority of the time, what you wrote is right. That's usually how they write it. So what's going to happen is you're going to take 21.6 divided by 100. And you're going to get 0.216. Now the reason we do this is because notice that the next piece we would have is P naught divided by P naught. Those are going to cancel each other out. And we just don't have it then. And that's why this process works. Now in the last part we have a cubed divided by a to the 0. Reminder about exponent rules. When you divide 2 things that have exponents, you subtract their exponents. So we would just end up with, it's kind of silly because we have a to the 0, but we would end up with a cubed. Which is why these ones where you're given P naught, you can kind of shortcut it because division doesn't really do anything. But the third one we're going to do a little later, we have to do it this way. But anyway, so then what you would need to do is you would need to cube root both sides. And remember, if you prefer, cube root would be equivalent to a 1/3 power. This is going to give us our a value. So our a value is 0.6. Did I round that obnoxiously? Oh, no, it's just literally 0.6. Good. So now we're not done. If you're given P naught, you're pretty much done because you have P naught, you have A, you can call it a day. But I want to do this one fully out just because I want to. So what you would do then, if say you didn't recognize that you had P naught, or you just want to find it anyway, you would take that 0.6 and plug it into whichever of those two original functions that you wrote down makes you happier. I'm going to plug it into the one with A cubed because the other one's not as interesting. So I'm going to plug it in, 21.6. Don't know what P naught is yet. I'm pretending I don't know what P naught is. To the third. 21.6 P naught 0.216. Divide both sides by the 0.216, you'll get P naught is 100. So that one actually didn't work out the way I wanted it to. I wanted it to be slightly off. But there wasn't a lot of rounding in that one, so that's why that didn't work. But anyway, I'll talk about that a bit more in a second. I know I'm rambling to myself right now. So that came out to be exactly what we were really expecting it to be. Yeah, that's why doing it the other way is worse algebra. So let me just reread your question, make sure. Could you go over one where the exponent of A is negative after you divide? Yeah. So say we had swapped those two equations. That's why I just personally prefer to avoid that. But what would happen is you would have, I know my battery is low, so 100 divided by 21.6. Ooh, this one has more decimal places, 0.629, let's take 4. And you would get A to the negative third. Now technically what A to the negative third is equal to is 1 over A cubed. So what you would want to do then is you would have to multiply the A cubed over to the other side. And then divide both sides by the 4.6296. Now watch this magic. Well, it's going to be slightly off because I rounded. Actually. Now technically that decimal is 0.2160013,842. But notice 0.216. Whoops, that was supposed to be a highlighter. And over here, we had A cubed equals 0.216. So if you try to be careful and put the one with the larger t value on top, you will avoid all that extra algebra that essentially just gets you out to the same spot anyway. So it's possible to do, of course, you just have to do a little bit more algebra because the negative exponent is technically in a denominator, so then you need to swing it over and swing the other thing back. And well. But that's how you would do it if that's what you got. I'll leave that over there for a couple more seconds while we do the second one in case anyone wants to take that down. Any questions on the first one? Okay. This second one, I'm going to go ahead and just do the cheat sheet way. Well, half cheat sheet. We're going to just use the fact that we have P naught to just plug in for P naught. So here we have 0.32 and 292.5. Now, the nice thing about if you're given P naught is that you can essentially cut the work in half. So P naught is 32. The other equation would look like this then. I didn't need to put parentheses around that A. I really don't even know why I did it, but if I just plug in the P naught into that equation, I have that. And at that point, I can actually just go ahead and solve for A and then I'm done. So if you have P naught, you can kind of cut the work in half because you can just take the other equation and solve for A. So we would divide both sides by 32. You could also do out the completely full process. That would still work here. Exactly what we did in problem 1. Write them both out, divide the two. Let's take all the decimal places here just to be super careful here. So you can do that full process as well. It's just if you have P naught, you can save yourself a little bit of time. Yep. That's true. I haven't really. So remember that P naught is our initial value. Where do I want to write this real quick for notes purposes? Now that might get confusing because you might think, well, then the starting value is all the way back here. What the other way to think about this is the initial value the wording might be throwing you off, but it essentially means you can find this. This is going to be at the point when x is 0 or t equals 0 or whatever the x variable is. So since we have a point 0, 32, we know that the initial value is 32. The initial value is always connected to the point where the x coordinate is 0. So that's why I know that the initial value is 32. That's a good question. Ugh. So if we square root this guy, or not, there we go. We get that A is, well, approximately 1.7, because we have 1.70018 blah, blah, blah. So approximately 1.700. So then our equation, our full equation, since P naught is 32 and we just found our A to be approximately 1.7, and the variable was still x. So now let me erase this thing so we can get to this third problem. Questions, concerns on that? So again, you could have used the entire full nasty process that we did over here. Would have been fine. You would have put the 92.5 equals P naught A squared on top of 32 equals P naught A to the 0. Well, if you want the algebra to be nice, divide the two, then you'd essentially be right here at that point if you did that. And then you'd finish it out. Now, I'm not seeing any questions. So this last one, I know the first one I forced us to do the full way, but this last one we have to do the full way because we don't know what P naught is because I don't know what that coordinate is. So the coordinates we're given are -2, 9.5. And then 1, 0.5. So this one we have to do the long way. So if I'm going to set these two up in our P naught A to the T form, I'm going to put the one with the larger T value on top to make my algebra nice. So that means I'm going to put the 0.5 one first. So 0.5 P naught A to the first. And then 9.5 P naught A to the negative second. Yeah, exactly what you said is perfectly correct, Pa. The initial value is the same as the y-intercept. And of course, the y-intercept is where x is 0. That is 100% correct. Awesome. Thank you for putting that in there. So we've got 0.5 divided by 9.5 will give us 0.05. Let's take 4 decimal places. Just because I'm feeling like 4 decimal places today. The P naughts are going to cancel each other out. That's the point. We're going to get 1 minus -2. So we'll get a cubed. Because you subtract the exponents. So then we'll need to cube root both sides to get our A value. So 0.0526 cube rooted. is going to be approximately, let's also take 4 decimal places again, 374, so that would round up to 7. I wrote way too large when I was doing that because I forgot that I have a whole nother step to do. So let me try to squish this a little bit. Back. Because we have the A value, but we still don't know what the P naught value is. So we need to find the P naught. Actually, what I'm going to do is let me squeeze it a little more in that direction, and let me do that, and then I'll squeeze over here. There we go. So what we're going to do is we're going to take that A value and plug it into whichever equation makes us happier. I would plug it into the A to the first one because dealing with a negative exponent is gross. So no, there's still not enough space there, so I'm going to do it down here anyway. So 0.5 P naught 0.3747 to the first. So that's nice because anything to the first power is just itself, so we don't need to add in an extra step there, so we can just divide the 0.5 by that. So 0.5 divided by the 3747 will give us that P naught is equal to, I'm on a 4 decimal place thing today. And so your equation, I'm going to squeeze in here. This one was a long one, sorry. 1.3344, 0.3747. That actually doesn't list the horizontal variable. I'm going to assume it was x again. So in that one, even though we didn't take the shortcut in number 1, we can't take a shortcut here because we don't have P naught. So we are forced to do the full way no matter what on this one. Questions, concerns on any of those? It's a long process. It's something to get used to. So I know, if this is the first time you've really seen it in your life or it's been a long time since you've seen it, it can be a little hefty. So let me know if there are questions. I'll leave it up for a couple more seconds before we move on. Okay, 5 more seconds in case anyone's still writing something down, and then we will move to, I believe it's the last set of questions in this this set, which is good. All right, I'll try to leave kind of that bottom piece in there. So suppose a city has a population of 400,000 at time t equals 0, where t is the number of years after 1990. If the city's population decreases by 2,500 people per year, find a formula for P of t, the city's population t years after 1990. So 2 things, decreases, and then people per year. So this is a set amount per year. So since it's a set amount, we've got a linear function going on here. So a linear function, we're going to have some y equals mt plus b. If you want to use p for population, actually they give us p of t, so sorry, I should be using that. P of t equals mt plus b. So our b is our y-intercept, so our quote-unquote initial value, if you want to link up the phrasings there. So that's going to be the 400,000, the starting population, and then our slope is going to deal with this 2,500, but since it's, sorry, I almost said the answer instead of the question. Since it's decreasing, it's going to give us a negative value. So our slope's going to be negative, so we're going to have P of t. I like to put the positive number first if there is one, but if you wrote it, nope, that comma. If you wrote it as the negative 2,500 t plus 400,000, of course, that's also correct. And again, we know it's linear because it's a set value per time. So if the city's population decreases, oh, we've got it decreases, yes, by 6% per year, find a formula for P of T, the city's population 2 years after 1990. So here we have an exponential, and again, it's because of the fact that it's given as a percent, and we also have decreases here, so we have an exponential. So we're going to have some P of T equals P naught A to the T. So our P naught is still going to be that 400,000, that initial value. Our A value here is still made up of 1 plus R. But the R here is, so it starts with 0.06 because that's 6% is the decimal, but then the decreasing is going to make that negative. So if we find the A value then, 1 minus 0.06, 1 minus 0.06 will give us 0.94. Yeah, if you wrote, writing plus the negative is still technically correct, but, oh, so maybe, so by definition, the A value is 1 plus R, but in this case, the R value turns out to be negative. So it's not that we change the A equals 1 plus R equation itself. It's just that R is negative, so it ends up being a subtraction. Does that make any sense? So it will end up being a 1 minus R in this situation. It's just technically we still take the definition of A to be 1 plus R, but R is just negative in that case. Maybe, I should clarify, maybe in life someone taught it differently. Not that I've heard, but if that's how you were taught it, and you were just taught that with decay, A is 1 minus R, that is, I mean, it'll find you the correct answer. So if someone taught you it like that, I will not go against that. But technically, it'll get you to the right answer. Technically, everywhere I've seen, we leave the 1 plus R alone and then just make the R value negative. Anyway, either way, your equation is going to end up being that 400,000 0.94 to the T. So once again, set amount per whatever, linear, percent, or if it says the word rate, even, exponential. Questions, concerns on either of those? Actually, since we have a little bit of time, let me go ahead and figure this out. So that is the end of these notes. Of course, I will be filling out the extra problems and putting them on Blackboard if you want to try them for extra practice. As mentioned in the beginning of class, the homework's going to be, the official due date's going to be shifted. What can you do right now? What you can do now is you can do problem 1, 2, 3, 4, 5. Sorry, I just remembered. I feel like someone asked me a question in an email, but I don't think I responded, and I don't know where the email went. Anyway, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1 through 10. Can't do 11 yet. I thought it was in this section, but I forgot it's not. So you actually can't do 11 yet. And you can do part of 12, but not all of 12. Can't do 13. 14. You can do 15. You can do parts of 16, so I'm going to put that under can't do. And then essentially everything else, 17, 18, 19. Yeah. And 17 through 26 you can't do yet. So there's less you can do than I thought. That's unfortunate. I mean, if you already know how to do them and you just want to get ahead, yes, this is homework 3. If you know how to do things with logarithms and you just want to get ahead of the homework so you don't have to deal with it next week, you can. But technically, from what we've covered, I was too vastly optimistic this week. So you can do 1 through 10 and 15, and there's a little bit of 12 and 16 that you can do. So obviously, none of the stuff that you can't do yet is not going to be on the exam. So the only reason what's the word I want? I don't know. The only reason I'm getting a little weird about that question, will this change the portion of the exam, is technically the answer is no, because I also just haven't told you exactly what's on the exam yet. So when I put out the review later today, there will also be a list of topics. So the topics will only cover what we've covered. It will only cover up to these exponential functions. There will not be anything that's in that can't do section on the homework is not going to be on the exam. That would be ridiculous. So what's going to be covered on the exam is essentially, I was really hoping we would cover more at this point, but we're going through things a little slower than normal, which is okay, but it's just we're getting a little behind schedule. So I just got to pull up. In the Hughes-Hallett, I know what it is. In the Hughes-Hallett book, it's essentially sections 1.1 to 1.5. In the Callaway, it would be 1.1, 1.3, 2.4, and 1.7. So essentially, in terms of the notes, it's going to run through functions, through exponential functions. So that is 1, 2, 3, 4, 5 sections of notes. So the rest of them that are on Blackboard so far, natural logarithm, exponential growth and decay, new functions from old proportion. Essentially anything that doesn't have the full completed notes on them will not be on the exam. So just those first, what did I say, 5 sections of notes will be on the exam. I will be posting the topics in the review later today when I get a chance. And so, again, I stated this at the beginning of class, but just again to clarify, homework 3 official due date will be 2/15. So essentially not this week, but next week. So that we can finish doing the portion of the stuff that you can't do yet. We should be able to finish that on Friday after your exam. Maybe a tiny bit necessarily on Monday. But that will be finished up, so then you complete that. I, again, would personally suggest you get this done now so that you can get the practice on those types of questions because they will be on the exam. But technically, now I haven't changed it yet in WebWork, so I will need to go back and change that later. So it's still going to say the 8th currently, but that will be changed by the end of the day as well. Sorry about that. I very much try to avoid changing homework dates and being confusing like that, but we got through a lot less than I thought we would this week. So it happened. I'll also make it an announcement on Blackboard just in case someone's not here or they forget or anything like that. So it's officially written out on text. Anyway, that's about it. If you have questions, feel free to stick around. Otherwise,